So what I want to share with you in the next 50 minutes is what has been my journey for the last 15 years now, which is studying high-performing technology organizations. And so this journey started out for me back when I was the CTO and founder of a company called TripArt here in town, where I was for 13 years. And so the most surprising part of this journey is that it took me straight into the heart of the DevOps movement, which I think is urgent and important for just a whole variety of reasons. So what I'd like to do is really share with you two things: why I think DevOps is so important, and hopefully this will resonate with you, and then the how of DevOps. I'd like to share with you as many patterns as we found, that we've found in these high performers that you can replicate in your own dev, test, ops, security shops to help get great outcomes. So in terms of the how, I just want to share with you, why I think this is so important. Because starting around 2006, what we found was that there was this downward spiral that would happen in almost any organization, large, small, almost any industry, profit, not-for-profit, and it was incredibly devastating. And so let me just share with you what that looks like, and it can always be told in 2 acts. The first act always begins in operations. I mean, how many people here would call your primary vocation, passion, operations? Raise your hand. Oh, not that many. Development? More? Okay, great. And then test? InfoSec? Oh, who tests code, right? InfoSec, anybody? All right, product owners? All right, okay. All right, this will be fun. All right, so for anyone who has spent time in operations, right, our primary mission is really to keep things running, right? Whether you're a DBA, a network engineer, a sysadmin, right? The problem is that the bane of our existence really is what we call fragile artifacts, right? The reason why we call them fragile is that every time we touch it, it blows up and causes a catastrophic amount of unplanned work, a catastrophic outage, right? The problem is, where do you find these most fragile artifacts, right? Whether it's fragile code, fragile environments, fragile organizations. Typically, it's in one of 2 places. It's in either the most critical revenue-generating operations of the organization, right, which the business depends upon, or it's in the most critical project, right, where we're trying to develop this capability that the competition has been doing for years, right, and we must catch up. The problem is that when you find fragile artifacts in one of those 2 places, something terrible occurs, right, is that the organization ceases to become able to keep the promises it makes to the outside world. And so, speaking as a married person for almost 10 years, I can say with authority, right, that when we break promises to someone else, we tend to overcompensate by making even larger, more audacious promises that we're even less likely to hit in the future, right? And so this happens to organizations as well, right? So whether it's features that we promise to customers, earnings per share customers make to Wall Street, or promises we make to the analysts to show that we can actually have a strategy and can execute. So organizations also make promises when bigger promises when they don't meet the old ones. That's not the problem. The problem is who's making those promises, right? And those are the product managers, right? Or the marketing people, or the whoever's, right? These are the people with the art majors, the writing majors, right? Who may not have the best idea of what technology can and can't do. And so, when that happens, right, a commitment is made, and now we're ready to enter Act 2, which are the developers, right? And just explain this joke, right? In operations, if you haven't spent time around operations people, you should know that the joke we tell about developers is, show me a developer who's not causing an outage, and I'll show you one who's on vacation, right? Or maybe it's the DBAs or the network engineers. They're all the same, right? But so from a development community, what we see are urgent, date-driven projects put into the queue where a commitment has already been made. And so that means in order to hit the date, we have to cut every corner that can possibly be cut, to ship on time, right? That means, sacrifice testing, usability testing, capacity testing, security testing, deployability, manageability, and so forth, right? And so Ward Cunningham, didn't he speak here last month? God, he's awesome. He framed it best, 15 years ago. He said, and thus technical debt starts to accrue. Right? Technical debt is what you feel the next time you try to make a change. And so when I visualize technical debt, right, I visualize it like this. It is all the crap in the data center, right, that accumulate over time, each time made with a promise that we're going to fix it when we have a little bit more time, right? And we never have more time. And so technical debt is like financial debt, is in that it accrues, it gets worse over time. So this, although bad, is not as bad as this, right? Bad for availability, right? You have cabling. You have an outage due to a cabling error, right? Which cable is it? It's that one, right? Right. But don't jiggle in the cables around it, because we know if something's loose, and if you touch the wrong one, right, the entire site goes down, like last month, right? So that's one downward spiral, right? At the end of each project, we have one more fragile artifact in production. But there's actually another downward spiral, which is even more insidious, which is that deployments start taking longer. So think of a friend who's been associated with an application that took 5 minutes to deploy. starts taking 10 minutes, starts taking a half day, starts taking a day, starts taking 2 days. And if you're fortunate enough not to be in a online services organization that have to be running all the time, 2 days is about the threshold between bad and intolerable, right? Because if you have to get something running by 5 a.m. Pacific time on Monday, you can still finish a deployment if you start early enough on Friday, and the ops guys work all weekend. But if the deployment is taking 3 days, now everybody has to do heroics in order to do a deploy. Developers, testers, DBAs, network engineers, ops people, and so forth. And I think that's what begins the real intertribal warfare between ops and dev, right? Because it doesn't stop there. Deployments can take a week, 2 weeks. I've seen firsthand a deployment that took 1,300 steps, 6 weeks. It would tie up something like 300 people, right? And so, and that's actually very bad for availability as well. So, and thus, the intertribal warfare between dev and ops. You have your developer checking in code at 5 p.m. They hit commit, right? They five each other in the parking lot, not realizing that they set the entire data center on fire, right, for the entire weekend. And so at this point, no one's achieving their goals. Features are taking longer to get to market. Deployments are starting to take longer. We have an ever-increasing number of sub-1 outages, right? And operations becomes increasingly mired in unplanned work, right? With losing the ability to actually pay down the technical debt, right? Does any element of the story resonate with any of you, right? So, isn't that interesting, right? So the question is why? Why does that happen? And I guess the thing that you should know about this when we are upstream, right, in dev, maybe in product management, is that what it leads to is a sense of hopelessness and despair, right? That people who are stuck downstream, what it feels like is we feel powerless to change the outcomes. We feel like we're in a never-ending horror movie, right, where the outcomes keep happening over and over again, right? And this is actually one of the worst things we can do to a fellow human being, right, is to deprive someone else's ability to actually change their own outcomes, right? So it's bad for ops, bad for dev, bad for test, but it's also bad for the organizations as well. So this happens everywhere. I just want to briefly describe why does this happen everywhere, right? Why isn't it just at Google and Amazon and Twitter and so forth? Why is it even at not-for-profits, higher education, and so forth? So I think there's two reasons why that give us reason to believe that we understand why this happens. The first is that this core chronic conflict is a side effect of how we're organized in technology, because every technology organization, we have to simultaneously respond quickly to urgent business needs. And what that means is ship features more quickly than ever, right? That's what the head of development might often say. But we also have to provide stable, reliable, secure, compliant IT services to the customer, right? And that means make no changes ever, right? Over my dead body, right? That's what the head of operations will say. And what I've learned over 15 years is that can quickly be arranged, right? Because time to market will always trump availability, security, and certainly paying down that technical debt. So that's one reason. The second is, why does this happen everywhere? Is that you don't have to be like New Relic, you don't have to be like Amazon, to have it necessary to have technology as a core competency. That every business is an IT company, regardless of what business we think we're in. Why do we believe that? Because 95% of all capital projects have an IT component, and 50% of all capital spending is technology related, right? And so for any business person to say, we're not Google, we're not Amazon, we're not blessed like New Relic, right? IT is not a core competency, I think is the height of self-deception, right? And I think the proof point, right, the utter visceral proof point of this is whenever we ask the organization, here's where you are, here's where we want to be, who's in the way? Who is conspiring to prevent the organization from achieving its grandest ambitions, goals and aspirations, right? It's IT, right? Somehow IT is constipating the flow of work, right? Making sure that the aspirations and goals never get achieved. And if you drill into the IT box, and especially if you have multiple development groups all feeding into one centralized IT operations group that runs as a shared service, the bottleneck is IT operations. And so I can speak from personal experience that is also a very, very uncomfortable place to be. So Act 3, it doesn't have to be this way, right? How do we know that? Because organizations like Google, Amazon, Netflix, Spotify, right? I got a chance to hang around these unicorns, right? And New Relic is absolutely one of them, right? These are organizations who are doing tens, hundreds of, or even thousands of deploys per day while preserving world-class reliability, stability, and availability, right? And so, the goal is really become to capture and codify, how they do it. And we're putting all those practices into something that we're calling DevOps. So for those of you who aren't familiar with the term, the seminal moment of DevOps, I think, was this presentation that was given at the Velocity conference in 2009. This is where all the unicorns hang out. Google, Amazon, Spotify, Twitter, they all show off the toughest engineering and ops problems there. And so even at the Velocity conference, though, this presentation was considered historically significant and shocking, right? Jalin Alspaugh was the VP of Operations at Flickr. Paul Hammond was the Director of Engineering at Yahoo. And they gave a presentation saying that they are doing 10 deploys a day, every day, right, as a part of daily work. And so had I been there, I was there the next year, but had I been there, I think my reaction would have been like this, right? 10 deploys a day, right? They're lying, right? Because, and if they're not lying, right, what they're doing is probably immoral, irresponsible, reckless, ill-advised, because what idiot would want to do 10 deploys a day, right? It's just not done, right? It's not proper. And so the one thing, and yet, I think that any professional in product management, dev, test, ops, security, if we can't figure out how to work in a value stream where that sustains this kind of tempo of work, right, we risk irrelevance certainly in 5 to 10 years. So let me just share with you a couple nuggets out of the Alspaugh-Hammond presentation, and then share with you the hows, right, what the patterns are on DevOps. So in the Alspaugh-Hammond presentation, they said, Spock is like the embodiment of development. Captain Kirk actually lets Spock sit on the bridge, actually asks him questions, listens to his advice, right? Whereas Scotty's embodiment of operations, Scotty is stuck in the basement, never gets invited to the meetings until we have a 7-1 outage, right? And then, it's like, Scotty doesn't say, sorry, pal, right? What did you expect? Because we've deferred planned maintenance for 3 years, right? Scotty still saves the day, but still doesn't, have the budgetary power, as Spock, nor does he sit on the bridge with them. As an information security person, who are we? We're like these people, right? But in the DevOps community, it is really one of boundary spanning. They're saying we need ops people who can think like developers and vice versa. And the result is not just this torrid summer of love, but it's really getting business outcomes that we've never seen before, right? 10 deploys a day. That was considered shockingly fast in 2009. And maybe that's not so considered so fast anymore. So one of the lessons I learned from the Software Engineering Institute at Carnegie Mellon University is that high performers in any profession always accelerate away from the herd. In other words, the best always get better. And I think that's absolutely happening in the world of DevOps and continuous delivery. John Jenkins at Amazon went on record saying a year and a half ago, they're not doing 10 deploys a day. They're doing 1 deploy every 11.6 seconds. Right? So that means it could be as small as a latent code release, a code deploy behind an behind a feature flag. It could be a release of a feature, behind the same feature flag. It could be 10,000 new environments all coming up, all considered 1 deploy. And so why is this important? I think it's because of this. Scott Cook, he was the founder of Intuit, or he is the founder of Intuit, and he said in this work that he's been pushing called the rampant innovation culture, he showed this quote, and when I saw it, it just blew me away. He said, during the peak 3 months of tax filing season for the TurboTax property, they did 165 deploys, production experiments, right? And when I read this 2 years ago, my first reaction was like, these guys are morons, right? What sort of idiot would want to do 165 deploys when it matters the most, right? Because the way I was trained, right, in the retail arena, we were so afraid of the production outage during the holiday season that we had to change fees from October 1 to December, to January 30th, right? So why would they do this? And the answer is in the following paragraph. I think it's because by doing these experiments, they were able to increase the conversion of the website by 50%, right? So in other words, had they waited till April 16th, right, when the tax filing season was over, they could have potentially lost their customers already to the competition, never again to return. So here's the 3 aha moments I had. One is the time to do production experiments, right, in the mode of lean startup is, codified by Eric Ries or so forth, right, is during peak traffic seasons, right? That's when you want to do your experiments. 2 is it takes great operations and development skills to be able to sustain, high tempos of change during peak traffic seasons. And 3 is I think this is how we genuinely create the capability that helps our organizations win. Right? There's a growing school of thought that says to win in the marketplace requires us to merely out-experiment the competition. And that means being able to make changes quickly, right, so that we can optimize our way to the optimum. So how am I doing here so far? Is this interesting? Okay. All right, so that was a shocker for me. So who's doing DevOps? It's certainly the unicorns, right? And I think one of the reasons why they're unicorns is because they are doing this. But it's also financial services, it's retailers, it's manufacturers, it's even government agencies. In fact, I should have added to their Department of Homeland Security, right? So the question is, why are these organizations adopting DevOps when often these are verticals that are typically associated with being very late adopters of things technology related? And I think the reason is that the value of adopting DevOps work patterns is even higher than we thought. So I was working with a company here in town, another great company, Puppet Labs. They're a configuration management vendor. And I helped them with Jez Humble. He wrote the continuous delivery book. We designed their DevOps survey of practice in 2012. That was year 1, and we did the same thing for year 2. So after benchmarking 4,200 organizations in year 1, there were 3 shocking surprises. The first of which was that the high performers were massively outperforming their non-high performing peers. As evidenced by, they were doing 30 times more code deploys, right? 30 times more frequent code deployments. They could complete them 8,000 times faster. In other words, how long did it take them to go from code committed, test set up, test run, production started, production deploy started, production deploy ended, successfully running in production? High performers could do it in minutes or hours, whereas lower performers would take months or quarters, right? So not only are they doing more work more quickly, but they're getting far better outcomes. When they do a production deploy or a production change, they're twice as likely to succeed. In other words, a change failure rate was 1/2 as large. And when something blew up, right, as Murphy does insist happen, they could fix it 12 times faster, right, the mean time to repair. So in our minds, this was just an amazing outcome. It was the first empirical evidence that we got. They could be more agile and more reliable at the same time. In fact, it turns out the two go hand in hand. The only way that you can get reliability profiles like this, where small, high change success rates, low mean time to repair, is when you keep changes small and frequent. So anyway, so I'll share with you kind of how they get there. If there's any book that I would recommend to anybody, it would be a book called The Goal by Dr. Eliyahu Goldratt. This book was written in the 1980s. It's credited for changing how a generation of managers have thought about plant operations. Has anyone here read The Goal? Yeah, yes. All right. For those of you who had, you should. It's integrated into most MBA curriculums. It's a novel about a plant manager who has to fix his cost and due date issues in 90 days. Otherwise, they shut the plant down. And so when I read this book 15 years ago, it was no doubt in my mind that the lessons being imparted in the book were relevant not just to operations, right, but to the IT value stream as well. And so our goal for over a decade was write the goal for the IT context. And that's what the Phoenix Project book was that we came out with last January, so a year and a half ago. So there are many things in common between the goal and the Phoenix Project. One of them is that both of these books have a Yoda, Mr. Miyagi-like character who speaks in very enigmatic ways, right, of which the protagonist is left to try to figure out, what does he mean? And so what I'm going to share with you in the remaining 32 minutes is the 3 ways. So the 3 ways are a set of principles that are intended to be the principles that you can derive all of the DevOps patterns from. So I'll share with you the 3 ways, and then for each one of them, the DevOps patterns that come out of it. And by the way, I think you can actually derive all the lean thinking from these patterns as well. So the first way is all about flow as we go from left to right in the value stream. It's between development and operations. And by the way, why Dev and Ops? Because development and operations are what's in between the business and the customer, right? So when the business says, here's where we need to go, that typically gets translated into engineering requirements that then must successfully transition into service in order to get, to get value delivered to the customer. So in the DevOps community, and so whether you're talking about plant operations or DevOps, the goal is always to maximize flow. So our favorite metric in the DevOps community is probably deploys per day, right? We know that Flickr did 10 deploys per day. We know that Etsy does about 300. Google does 15,000. Amazon does about 23,000. But in the lean community in manufacturing, the most important measure is not deploys per day, right? It's instead it's lead time. So in manufacturing, lead time is measured by how quickly can you go from raw materials from one end of the plant to finished goods at the other, right? And there's a deeply held belief that lead time is the best predictor of quality, customer satisfaction, and employee happiness. And I think that's absolutely the case for DevOps as well. So I guess you could say the equivalent of lead time in DevOps is feature committed, right, to code committed to running in production. But for all, the metric I'd like to really focus on is a subset of that. how quickly can we go from code committed, through the test cycle, through the deployment cycle, and running into production. And so just as a benchmark, right, think of a friend associated with an application. How long would this friend take to actually go from code committed, test set up, test run, test passed, deployment started, deployment finished, running in production? How many people would say for their friend minutes? Raise your hand. Hours? Days? Weeks? Months? Quarters. Yeah, quarters can happen, and especially if it takes a long time to get a test environment, right? That about matches the distribution we saw in the 2 years of the DevOps survey of practice. So I think, just to repeat, lead time I think is probably the most effective measure to manage around, right? Because it is a great predictor of customer satisfaction, quality, and employee happiness. But it's also, I think, a great predictor of this, right? The cultural distrust between development and operations, right? So when there's a long lead time, when developers or product owners say, let's deploy next week, if the operations staff, if we say, holy crap, you can't deploy that piece of crap, right? That's not even designed to run. You can't even get it to run on your laptop. Typically that's going to be associated with long lead times, right? And so long lead times are not only a great barometer of a predictor of cultural distrust, but it's also a great predictor of catastrophic deployment outcomes, right? So think of the worst deployment disasters in the last 20 years. Toys R Us 1999, Amazon 2001, maybe Twitter 2009, right? Maybe healthcare.gov. I think typically you're going to find associated with each one of those are very long lead times. And I think the reason is that one of the major contributing failures of the worst deployment failures we've seen is that the first time the code was being integrated with the environment as defined by database, everything besides the code, right? Database, operating system, virtualization layer, networking, so forth, was during the deployment, right? So if you believe that, then the countermeasure really becomes how do we make operations and everybody able to create environments available to whoever wants one on demand. We don't open up a ticket. We don't open up, we don't have to wait 42 weeks, right? And the constituency who gets probably the greatest benefit immediately is development, right? Because it means that we can test and run our code in a production-like environment at the earliest stages of the project. So among every one of the high performers, we see that this capability, right? We have one common build mechanism that builds the dev, test, and prod environments all at the same time. They never have to be synchronized because we've just eliminated that category of error, right? Because we have a common build process. And the way we want to use it is that we want to make sure that even in the first development intervals or sprints or whatever, that it's not sufficient to have potentially shippable code at the end of each interval, right? It has to be demonstrated in a production-like environment. Right? So the reason why that's so powerful, I think, is that it means that we never are fooling ourselves to think that we have a feature complete when it has never been tested in a production-like environment. Right? So that means by the end of the project, we'll have done that integration together. By the end of the real project, by the end of the sprint, by the end of that project, whether it's 2 months or 9 months later, we'll have done that integration hundreds or maybe even thousands of times. And that takes a whole category of error off the table. So, I love this quote. You're only as smart as the average of the top 5 people you hang out with, right? So which is the reason why I love meetups like this and why I feel so crappy that I have to leave in 27 minutes. But one of the corollaries of that is that when you hang out with smart people all the time, you feel dumb all the time. So let me share with you one thing that made me feel very dumb. Jez Humble's been helping on this project we're working on right now called the DevOps Cookbook. And he was actually explaining to me a case study that I've seen 3 times before in the last 3 years, but each time I sort of missed the real big point. So let me tell you about one of them, because maybe you have a friend who probably missed that point too. So one of the most amazing examples of continuous delivery and the power of small batches is the Facebook chat story. And so when the first time I heard the story, I kind of rolled my eyes and dismissed it because I wrote a chat server as an undergraduate. This seems like a trivial problem. But apparently when you have to support 100 million users online at the same time, right, it's a very tough problem. It's order n cubed, right? It was actually one of the largest technical undertakings that Facebook had gone through. It was one of the largest project teams they had assembled. It was their first Erlang implementation in the back end, right? So every day for a year, they were checking code into production in a disabled state into production, right? So that's what continuous deployment is all about. Each code commit results in a production deploy. But but the real big shocker was, how do they use that time? For an entire year, they were using every active Facebook browser user session, as a test harness. They were sending invisible test chat messages to the backend servers, right? So when it actually came time to release the feature and announce to the world Facebook chat is available, they went from 0 users to 93 million users overnight without a hitch. Why? Because they were testing in production for almost a year with production-like loads, right? And so that's astonishing, right? So I was like, oh, that's amazing. And by the way, I thought testing production was a joke, right? That was like the worst thing you could do as an ops guy, right? But so what does it mean? It means that we are decoupling the feature, the production deployments, meaning the tactical deployment of code, from the feature release. So in my mind, the mental metaphor I use is Operation Desert Shield, right? Every day for a year, thousands of men and materials were being staged into a staging environment, right? But there was only one marketing release event. Right, so one of the best things that we can do as a dev and ops group is to deploy every day and to be able to not cause carnage or chaos and disruption when we do that. And we do this by shipping code in a disabled state behind a feature flag. It means that we have to require all developers to check in code daily. And by doing this, we can free ourselves from this learned behavior that deployments hurt. Right? If we can do it during the middle of the day as opposed to on weekends, right? It means that operations people can have a normal life like everybody else, right? As opposed to sacrificing our weekends, for years on end, right? And so what a game changer that is for not just operations, but the entire community around them, including their families. Just briefly, I got this graph a couple months ago. He's from the chief architect at CSG. They're the largest bill printing company in the US. So if you get a paper bill from a wireless carrier, chances are it's from one of their operation centers. They did an experiment from their flagship legacy app. They cut the deployment interval by half. In other words, they did the deployments twice as frequently. What happened? The number of incidents went down by over half. Mean time to repair went down by over half. Right? And I'm like, wow, Scott, that's great. Thank you so much. He's like, you actually missed the point. The customers actually got value in half the time, right? That's the real win. So not only is it good for dev, it's good for ops, but it's actually good for the customer and the business as well. In the spirit of time, let's just keep going. So what are the outcomes of the first way? We have a single repo that for code in the environments. In other words, another thing that every high performer did is they had all production artifacts checked into version control, ideally in the same repository as developers, right? So that changes communication paths as well, right? It's like now dev and ops can always see what each other are doing, and that not only reduces surprises, but actually reduces risk as well. We have determinism in the release process. We have a common dev, test, and prod environment that are all properly built and synchronized long before the big deployment. And we are freeing ourselves from this learned behavior that releases and deployments hurt. And by doing that, we can shrink lead times. We go from months to weeks to potentially days, minutes, or hours. And I think that what we want is on demand. And I'll share with you some examples of that. And by reducing lead times, that's how we increase the deployment cadence. The faster cycle time and increased frequency of deployments. How am I doing here so far? Is this thumbs up? Okay. So the first way, flow, left to right from dev to ops. The second way is all about the reciprocal. How do we create a fast flow of feedback from downstream to upstream? In other words, how do we make sure that whenever something bad happens downstream, whether it's a service impairment, service outage, security breach, how do we feed that information to the very beginnings of the development pipeline so we can ideally prevent it from happening again? And if we can't prevent it, at least enable quicker detection and recovery. And so the goal of this is really to shorten and amplify feedback loops, which is, I think, one of the common goals of almost any process improvement methodology. And so the paragon, I think, in the manufacturing world would be the andon cord. And so when I got trained at the University of Michigan in the what they call the Toyota Kata, it really is true. Manufacturing plants modeled after the Toyota production system have this thing called the andon cord. It's this cord that every employee in the plant is trained to pull whenever something goes wrong. That means at the work center, if the parts if they're defective, if they're not there, if the work takes longer than documented. If it takes 1:20 versus 50 seconds, you pull the cord. So what happens when you pull the cord? The entire assembly line stops, right? Trucks stop coming out the other end, right? So can anyone hypothesize, speculate, in a typical Toyota plant, how many times is the andon cord pulled in a given day? Order of magnitude. 0, higher. 10, 50. 3,500 times per day. Right, so why, right? What sort of idiot would pull the andon cord 3,500 times a day? And when you ask, apparently, when you ask people up and down the line, and you know, whether it's a line worker, supervisor, right, manager, you know, regional area vice president, the answer is all the same. If we allow technical debt, if we don't pull the andon cord, what will happen is technical debt will accrue downstream, where it becomes much more expensive to fix, maybe even impossible. And they'll say that's the only way that we can sustain a build tempo of 2,000 vehicles per day. Right? In fact, that number is out of date. Turns out at the average Toyota plant, it's now 4,000 vehicles per day. Right? So if you can just take a moment, that's one vehicle every 55 seconds. How many times have you seen in a given day something that if there were an andon cord, someone should pull it? Right? So that's the goal, right? That's the end state, is create a culture and a form of feedback where we can extend that culture from not just continuous builds, continuous test, continuous integration, continuous deployment, but make sure that anyone can pull the andon cord, especially operations, because we actually see the downstream consequences first. And oh my gosh, so let me share with you 2 quotes that are some of my favorite. And by the way, one of my favorite people on the planet is Patrick Lightbody. I should really update the title. Is VP of Product Management at New Relic. But he said 3 years ago about his browser mob experience, we found that when we woke up developers at 2 a.m., defects got fixed faster than ever, right? And I'm like, oh. It was like a huge light bulb for me, right? Because he didn't just hate developers, right? He didn't wake up random developers at random times, right? What he was evidencing was that in order to have shared goals between dev and ops, you have to have shared pain, right? And so Werner Vogels, the CTO of Amazon, would put it even more succinctly. You build it, you have to help run it. So, I think one of the reactions, especially in the development community, is, DevOps, oh my gosh, what a bunch of assholes. They're just trying to give us pagers, right? What's the fun in that? But I'd like to paint a different narrative. And this comes from actually Tim Tischler, just down the street here at Nike. He says, as a developer, and now he heads up the DevOps initiative at Nike, he said, there's never been a more satisfying point in my career than when I got to write the code, deploy it, got to see it running in production, and when something broke, I got to fix it, right? And I think that's kind of the end state we want to create, where developers are productive, we don't have to spend a lot of time in committee meetings, right? And we have the confidence to deploy and see it running. So I think the equivalent of Toyota in our space is Google. They have 15,000 engineers working on 4,000 simultaneous projects, right? As a little mental benchmark, HSBC, the large European bank, they have 18,000 developers, right? So who actually is, they have more developers than Google, but they probably have a tenth of the number of projects in flight. So Google has one source code repo, billions of files, 5,500 code commits per day, each one of those resulting in a code deployment, in a production deploy, right? 75 million test cases run daily, right? It doesn't hurt that they have probably more servers than God does, right? But why? Why would they invest so much in automated testing? And I think Aaron Massari, as part of their SCM group, their developer productivity group, they said, it's only through automated testing that we can transform fear into boredom. He said, imagine how paralyzed your new engineer is, to do a deploy when they know that any change of their changes could actually take down every Google property all at the same time, right? And you can't get over that fear until you know that there's a safety net that will keep you from doing something catastrophic. One of the things that you see in DevOps organizations is that engineers, dev or ops, are required to do a production deploy on the first week, like at Facebook, or in the first day, like at Etsy. So, and if something goes wrong, they don't fire the engineer. They'll just say, wow, haven't seen that one before. We got to add one more test to make sure that doesn't happen again. So let me show you some patterns. At Google, there's this kind of amazing policy that before something gets taken over by IT operations, by what they call the site reliability engineers, kind of Uber system administrators, there's a policy that developers must self-manage their own code for 6 months, right? At least 6 months. And so the question is why, right? And apparently the answer is that even at Google, where they can hire anybody on the planet, the scarcest talent are these SREs, the site reliability engineers. So the worst thing that we can do is have developers give them fragile code that plunges them into firefighting where technical debt accrues, right? So the countermeasure is just making sure developers can manage it first to make sure that it's in a production-ready state. And they have something called a hands-off readiness review, right? That's like a production checklist. But I think the best evidence of the mutual respect between dev and ops at Google is what happens when an application is in service, taken over by IT operations. What happens when it goes fragile? And so apparently at Google, at any point in time, the IT ops group can trigger the handback clause, right? Essentially they say, you know what, your application is destined for great things, but here's your application back, right? Your puppy is pooping all over the floor. She's destined for great things, but bring her back when she's house trained, right? And we'll run it through we'll even help you house train, but you have to take over, production responsibility. So how many people here have been in a point in time where they would love a handback clause to somebody, right? So, and that's required for, for feedback. So, hey Joe, good seeing you again. We were hanging out at DevCon, ChefConf, and Red Hat Dev Nation last week. Anyway, so another form of feedback that is far less extreme is this culture of creating production telemetry. So this is John Alspaugh from the famous Alspaugh-Hammond presentation. He's now SVP of Tech Ops at Etsy. I think they're doing about $800 million of revenue on a run rate basis. But the reason why I show him is not to show his face, it's what's behind him. They've gone on record saying that because there's a culture that in development, that if it's important enough to implement, it's important enough to instrument. They have 250,000 production metrics being generated every day. So at the feature level, application health level, database, storage, OS, networking, virtualization, everything feeds into one big thing. And the expectation is if a developer writes code that they don't instrument and feed into that system, they're just lazy, right? Writing telemetry shouldn't feel like doing a database schema change. And so they invested a tremendous amount of energy in this thing that they called StatsD and Graphite, where you write one line of code, and then you boom, right? You have your 250,000th and first metric. So in this graph here is the number of logins in this case. All the production lines, all the vertical lines are a production deploy, right? So no developer would go home, after they commit code without first verifying that, the functionality still works in production. They haven't flatlined, half the graphs, right? If this thing is actually a feature capability, they would actually be running this as an A/B test to make sure that the business outcome's improved, right? If it doesn't improve, right, they would actually turn it off, right? So one of the hallmarks of DevOps organizations, and it's, this has shown up in every tour I've done of one of these DevOps shops, is everyone's looking at these metrics, right? This is Rally Software, so they're the agile planning software community. This is Sharoon Reddy, the director of operations. So on the top you see a bunch of production metrics. In fact, I'm sure New Relic is feeding some of those. They're actually going to Tableau, so that's a statistical analysis software. They actually have an statistical engineer in the ops group that knows R and uses Tableau, right? And everyone's looking at these things. And so right before I had taken this picture, someone had whispered into Sharoon's ear, the dilithium crystals are fluctuating, we're down 30%, right? And everyone's looking at these metrics. They're trying to figure out, is it a database issue? Is it a storage issue, right? And I actually asked them a question that I think offended them. I asked, are we actually watching a Sev1 outage in progress? Is this? And they're like, no, right? We just found a variance that we just want to understand before it causes a larger variance, right? So I think that's the other goal of high performers. They want to find variance early before it causes a larger variance. Let me share with you a sneak preview and one of the biggest surprises that came out of the year 2 of the DevOps survey of practice. So in year 1, we benchmarked 4,200 organizations and found these signals of performance, right? And by the way, what were the high performers doing in year 1? We found that every one of them answered yes to these 2 questions, and almost every low performer answered no. The 2 questions that every high performer answered yes to was, are all production artifacts checked into version control? And is there an automated code deploy process, which includes creating environments available on demand? Right, and so in the world of Puppet, Chef, Docker, right, there's just no excuse not to be doing these things, right? I mean, that's probably why so many of DevOps success stories focus around deployment initially, and I think that shows up in the benchmarking as well. So in year 2, we benchmarked 9,600 organizations. We're just going through an analysis right now, and the goal was really to understand the other kind of areas that cause high performance. And I got to tell you, it is one of the biggest shocks I've had in my whole journey. Especially after doing now 15 years of benchmarking, this is still probably the biggest shock I've had. So what we found in year 2 was that the single best predictor of not only IT performance, right? IT performance is measured by lead time, change success rate, deployment frequency, and mean time to repair. But it's also a predictor of organizational performance. And in the literature, right, organizational performance is a proxy for competitiveness in the marketplace, shareholder return, return on assets, compounded annual sales growth, and so forth. The top predictor of IT performance and organizational performance was what they call the Western typology model. In other words, are they a high trust organization or a low trust organization? So in low trust organizations, messenger of bad news are shot, responsibilities are shirked, bridging between functions, right, between dev, test, ops, are discouraged, we cover up failures, and new ideas are crushed. Where in high trust organizations, very much like I'm in the spirit of the agile small teams, we seek information, we train people how to tell bad news, responsibilities are shared, we encourage bridging between functions. Failure causes inquiry. We don't fire people, but we want to learn out of earnest need, right? How do we prevent it from happening again? And new ideas are welcomed. In my mind, this is shocking, right? It means that I think the biggest management challenge we have in this decade is how do we go from a low trust organization? How many people here have a friend who worked in a low trust organization? How many people here have the benefit of working currently in a high trust organization? Yeah, so I see this at New Relic, and it's just amazing, right? I don't know how you go from low trust to high trust, right? Because what we learned in the Knight Capital failure, right, is the low trust countermeasures. When you have a deployment error that causes a $440 million trading loss, and you have to, assuming the company wasn't liquidated over the weekend, right? How do you say the right action is not one more approval level needed in the change request form, right? And do, quote, more testing, which actually increases batch sizes, which we know decreases change success rates and increases mean time to repair. How do you convince the powers that be that the real countermeasure is the only person who should be approving decisions to go into production is the person doing the change, and that we need to do them more frequently, right? I think the way most people will hear that is, we've screwed you before, and now you want to do it more frequently with less supervision. Yeah, get out of my office, bam, right? I mean, I don't know how you do that, and yet, all the data says is that that's the way we need to go. So, that's one of the reasons why we're holding this DevOps Enterprise Conference, where, we want to see how people who are stewarding large, complex organizations with legacy infrastructure, how are they making that transformation? Because I think, it's something that the rest of us need to know. Am I making sense? Yeah. And by the way, when I was hanging out with the New Relic team watching their deployment, that happens, was it 3 times daily here for the APM part? I mean, it really is true, right? It's like when there's a failure, right, they're like, ooh, gosh, that was interesting. Let's huddle and make sure that doesn't happen again. There's not a lot of blame, right? There is no blame. So anyway, that's, oh, by the way, one of the biggest shocks was like watching how John Allspaw, right, from the famous John Allspaw Hammond presentation, he was relaying a story of how a junior UX engineer, he wanted to do a HTML deploy, right? And he asked, John, is it okay for me to make a change? To which he responded, as the EVP of tech operations, I don't know, is it? Right? I mean, in other words, he took no responsibility for the quality of the change, right? He pushed all the responsibility to the person who wanted to do it. And the question instead is, instead of who approves it, the question becomes, did you get the smartest people you know to look at it? And did you do everything you can to gain confidence that it's going to do what it's supposed to do without causing bad side effects? I think that we rely not on change approvals, but on peer review and automated testing, right? So what does this mean? The days of reviewing and approving changes in a 70-word essay contest and change approval meetings, right? Those days are coming to an end. Instead, where do we get assurance? It has to be from the automated deployment pipeline. When something goes bad, it's not one more level of executive approval needed to make the change. Instead, it's one more test in the deployment pipeline to flag a change and make sure it doesn't get into production. If you can't prevent it, at least then the countermeasure is put more instrumentation in it so that you can detect it quicker and recover faster. Another form of feedback is, if you're in a development group, if you are, scrumming and retrospecting, right? Invite the ops person, right? And the ops person might be able to give some good feedback like, holy cow, the deployment last week was the worst we've had in 5 years. Really wanted you to know. By the way, I'm even coming to the meeting with some ideas on what we can do about it. So outcomes of the second way. Defects and security issues get fixed faster than ever. We now have a deployment pipeline that's fast and a reciprocal flow of feedback, right? That's awesome that we can now replicate across our entire product portfolio. All groups are communicating and coordinating better, and everyone's getting more work done. So that's the second way, and then the third way is, first way, flow left-right, second way, right-left, and the third way is really about creating a culture of continuous experimentation and learning. And I would say that Westrum model, high trust, really is a part of that. In other words, just because we've done it the same way for 20 years, right, doesn't mean that we have to do it the same way tomorrow, as long as we know what the goals are. And the other piece is, there's an emerging school of thought that says, whether it's learning to play a musical instrument, or training the special forces in the military, or training a sports team to win, it's always better to practice 15 minutes a day, every day, than it is to practice once a week for 5 hours. So in the DevOps space, I think the best adage is coming from Adrian Cockcroft, who was the architect at Netflix. He said, our goal is to do painful things more frequently so that we can make it less painful in the future. And so even though we make life hell for developers sometimes, the reaction we get is, oh, thank you so much, because we know this will make future rollouts go more smoothly. And by the way, he's now left Netflix after 8 years, and now he's a technical fellow at Battery Ventures. So I think the best evidence of the efficacy of this philosophy was during the first Amazon EC2 failure that happened in 2011. So many of you might remember, running something in EC2 and then it going away on April 22nd. Every customer who was using Amazon EC2 went down, except for one, Netflix, right? And so for weeks we're asking, what is Netflix doing differently that resulted in such a different outcome for them? Was there some super secret feature that only Netflix knew about? And they revealed all in a seminal blog post that they came out with. And essentially they said two things. One was, the first engineering decision they made was, we can never depend upon Amazon for availability, right? They will never be there when we need them most. Consequently, led to number two. In order to survive failure, we decided that we had to fail all the time, right? And this is when they unveiled, of course, this thing called Chaos Monkey, right? This audacious piece of this code that ran on every production server, and it would randomly kill processes and entire compute instances all the time in production, right? At large-scale fault injection, right? So you can imagine, right, running this in production, right, you quickly end up with more resilient code, more resilient environments, and a more resilient organization very quickly, right? So just two quick things that they don't tell you about. Before you run Chaos Monkeying in production, run it first in test, right? That's one. Two is actually, now they have actually engineered even bigger and bigger fault injections, right? Called Chaos Gorilla, Chaos Kong. They actually run servers out of disk space. They're basically constantly injecting faults into production. So what are the lessons we learned from this? Is that if we really care about availability, right, we have to be fearless about being able to practice. The last technical practice I want to leave with you is this. This is especially for product owners. Marty Kagan, a hero in the product management space, said the primary responsibility that every product owner should know about is that 20% of the dev and ops cycles get taken off the table. They're not for product owners to use. They are there for ops and dev to use however they best see fit. Non-functional requirements, right? Technical debt, paying down, right? So this is where we fix. We can do the refactorings, the re-architecting, fix the deployment issues. And one of the best examples of this is, for him, the war story was eBay. right? As a VP of product management at eBay, he said, imagine telling all your friends that you haven't shipped a new feature in 2 years because the entire organization is always firefighting and suffering from site down issues, right? So if you don't pay your 20% tax, right, you will spend 100%. You'll have 100% tax paying down technical debt. And so that's how we go from here, that turns into this, right? If you can create the coalition and the collective will to solve these problems, right? Like Facebook does with their hack days. Once a month, everyone works on anything besides the feature. They self-organize. Like Twitter, you end up in a situation like this, right? And this is how you have these massive transformations that just change the entire organization. LinkedIn had a code freeze for 2 months after they went public, right? Because it became so dangerous to deploy code. And we talk about a brave thing to do. So why do I think this is important? This downward spiral happens everywhere. It causes hopelessness and despair downstream, right? And by the way, and so there's another dimension as well, right? Which is the business value that can get created from this. A fellow co-author and I, we did a calculation where we asked, how much business value is there on the table for us to reclaim if we could just have the amount of waste in the IT value stream and redeploy it in a way where we can get 5 times the value? And the answer we came up with was $2.6 trillion per year, right? $2.6 trillion per year, right? So, that's more than the entire economic output of Germany, right? So think about what that does to productivity, standards of living. There's no doubt in my mind that the next big surge in productivity, the likes of which we have not seen in 30 years, is going to come from solving this problem. And the way I think about this number is through the eyes of my 6-year-old and my 2 4-year-olds. You put $2.6 trillion into the economy over 20 years, you make a huge dent in things around the levels of wealth, health, and prosperity in the world. And those are the things that actually can change the big knobs like world peace. So I think this is a problem that is awesome to solve. So let's do it. For those of you who are interested in this, we're throwing this DevOps Enterprise Conference on October 21st to 23rd in San Francisco. And our goal is for a conference focused on horses, not unicorns, right? The unicorns are fine, right? What we want to do is, show how organizations and complex organizations with tons of legacy, let's figure out how they're doing it, capture and codify that so that we can increase the rate of adoption, increase the rates of success. So if you're interested, just email me. The first half of the book is free because our goal is to positively influence the lives of 1 million IT professionals by the year 2017. So books are a great way to do that. But free, let's give away half the book. I'm hoping that if you know anyone who you think might benefit from it, just Google Phoenix Project free excerpt, put in your email address, you'll get a PDF file back. Give it to whoever you want, and I'm hoping that 5% of those will come back, and their response will be, "Holy cow!" Right? That's happening to us, right? Are you saying that you have some ideas on how to turn this around? And my hope will be that you will find your fellow travelers to absolutely replicate these DevOps transformations in your own organizations. So with that, and the DevOps Cookbook, first draft is coming out next week. If you're interested, email me. And with that, thank you so much. Sorry I need to run. The consequences are grave if I'm not home. Thank you.